right, let's go ahead and start. So the first thing I want to go is tabs. Let's talk about tabs. Tabs, my friends. Let's take an example. The best scenario of explaining a tab is by taking an example. So let's take this example. An example is sitting right here. Mr. Curry decided single-handedly to go tab this feeder and have an overconfiguration device that feed this panel and another overconfiguration device that feed another overconfiguration device. Oops, let's take that tab all the way. I keep forgetting it's a tab. So tab is going to be overconfiguration device here. So here, overconfiguration device is here. And so here's a tab. These are my conductors. What you guys are looking at is a gutter here, and you're looking at an overconfiguration device, and you're looking at a panel. You're looking at a panel here, and you're looking at a panel, okay? So we have two panels tabbed from a feeder. Anybody has a problem with that? Two panels tabbed from a feeder. What does tab means? Anybody knows what a tab means? What does a tab mean? When you tab a feeder, what does a tab mean? Splicing. So this is what you're looking at. The blue are devices. The blue are boxes. So this is a circuit breaker box. This is a gutter, and this is a panel number 2, and this is panel number 1. Anybody has a problem with that? I decided single-handedly, Chad Carey, to take a feeder and bring that feeder, guys, in a gutter that looks similar to this, an enclosure with an open cover. I brought the feeder right in here, and I tabbed the conductors, as in spliced the conductors. See these big black dots are tabbing the conductors. We're tabbing them. Tabbing means you splice them. Here's the feeder, phase A coming. You grab phase A with a lug or a connector, special connector, and you take it all the way to the panel 1. And the same thing, phase A to panel 2, then phase B and C to panel 1 and panel 2. Everybody knows what tabbing is? Splicing. It's like wire nuts, but it's usually in a bigger lugs, and bigger connectors, not lugs, bigger connectors. Any question, guys? So what you're looking at basically 4 devices, 4 equipments. These are 4 equipments. Spencer, one equipment is circuit breaker box. The other equipment is a gutter, which is an open enclosure with a cover, right? You've seen it. If you look around the walls, it looks similar to this, except it's metallic in this case. And these are panels like you're looking at the one right on the wall here. Questions about what we have first? Any question about what we have? Why would we use a gutter? Why would we use this system? Cheap. The key word for using tabs is cheap. What's the alternative of why is it cheap? Because now I don't have to carry these two feeders all the way to the main panel, more conductors, and number 1, I have to have another panel, a panel here instead of just one circuit breaker. I have to have a panel because I need 2 circuit breakers to put right here. Then I need a panel for these 2 circuit breakers. Plus you can tab, but by the way, you can tab multiple things out of here. Multiple things. You can tab 20 things out of the feeder. If you have 20 things that you need to tab, if you don't want to tab, then what's the alternative? Is you bring a panel like this, a big panel, and you feed them direct from the panel. So you added to your expense another panel. The only reason why we tab is cheaper to do business. Engineers don't like a whole lot of tabbing. Electrical contractors love them. You put the gutter on the wall and you tab it. Easy to use, cheaper. Okay, am I clear about why do we use to tab? Cheaper. What's the alternative of tabbing? If I don't want to tab, what's the alternative of tabbing? Is to go directly into the panel and feed branch circuit or a feeder directly from the panel, which is more expensive. Okay. Questions about why we tab? Everybody is okay why we tab? Now let's go size tab. Now what does a tab mean? When they say a tab conductor, anybody knows what a tab conductor means? What is a tap conductor? Is this conductor from the circuit breaker here all the way to the panels a tap conductor? No. A tapped conductor, guys, is a conductor that does not have an overconduction device at the point of receiving power. For example, here's a point, this conductor here. Do you think where did this conductor receive its power? Right at this point here, right? Does it have an overconduction device right at the point of receiving power? No, then it's a tapped conductor. Let's look at this conductor, that main one. Does this conductor, the main one, all the way up here, is this conductor a tab? That guy here, is this conductor a tab? This one here?
No.
No, why? Because it received its power. It has an overconduction device at the point that it received its power. It's not a tab. So the tab is when you have a conductor and that conductor does not have a circuit breaker located at the point of receiving the power. Okay? Let's take an example. So that's why it's a tab. There are two examples I want to do, guys. Number one, I want to take a 10-foot tab. Here's my 10-foot tab. This is 10 foot. And this one, and I want you to use your imagination because I did not draw them to scale. So you can use your imagination here. And this one is a 25-foot tab. 10-foot tab and 25-foot tab. They're not to scale. They look like they're the same distance, right? But you guys are going to use your imagination and imagine they are 25 and 10-foot tabs out of this feeder. Okay, so everybody knows what we have. We have two panels tapped from a gutter, 25 and 10-foot tabs. Anybody has a problem with that? Okay, now to review, a quick review of the tab rules. You're going to find your tab rules in 240.21b. The rules 240.21b, and in particular, the one that we're going to concentrate on today is 1 and 2. We're going to leave the rest for another time. 1 and 2. So, Mr. Erbab, if you want to follow up the rules of the tabs, you're going to go to Article 240.21b as in boy, and 1 and 2. Okay? Everybody's there? All my friends are there? Yeah. And my non-friends are there too? All right. If you guys look at that, this is just a quick review, the tabs, the 10-foot tabs. Here's what the 10-foot tabs tells you guys. Rule number 1, you can't go further than 10 feet. Duh, Chad, it's called 10-foot tabs, so it goes without discussion, right? Rule number 2, the tabbed conductor must be terminated, the termination at an overcurrent protection device that does not exceed the ampacity of the conductor. So the tabbed conductor must be terminated at a device, overconduction device, that does not exceed the ampacity of the tabbed conductor. So number 2, you have to protect it from physical damage. So you have to have a conduit in between them. That's number 3, conduit in between them. So 10 foot, number 1 is 10 foot. Number 2, guys, it has to terminate. The tabbed conductor has to terminate in an overconduction device that does not exceed the ampacity of the conductor. Tabbed conductors. Number 3, you have to protect them with a conduit from the time that they come out of the gutter all the way to the time they get into your area. So with the conduit, so that's what they're talking about. So we put the conduit here, Chad. Hey, don't worry. Here's my conduit, right? And tab number 3 is different for both of them. Tab number 3 for number 10, guys, it says the overcurrent protection device for the feeder cannot be more than 10 times the conductor ampacity. 10 times the conductor ampacity if it's 10 foot, and the overconduction, this conductor for 25 feet cannot be less than 1/3 of the overconduction device. Repeat, these are very important rules. For the 10 foot, you can look at it either way. The 10 foot, the conductor amps cannot be less than 1/10 of the overconduction device. 1/10 of the overconduction device. For the 25 foot, the rule is the conductor amps, the tab conductors, cannot be less than 1/3 of the overconduction device. Let's take an example. Makes it very clear when we take an example. Okay, Spencer, my friend, should we throw a 600 amp on that circuit breaker and tab it? Anybody has problem with that being a 600 amp circuit breaker? Anybody has problem? Should we make it 4 or 6? 6 is good. So let's have a 600 amp circuit breaker. I have a 600 amp circuit breaker. Anybody has a problem with that? No, no problem with that. Okay, so I have a 600 amp circuit breaker. The first thing I need to size is I need to size the feeder that we need to tab. There is the tabbed conductor. The tabbed conductor. So the feeder that we need, that we're going to be tabbing. The feeder, that red feeder that we need to tab. So let's go ahead and size right here. Sizing the tab feeder. The tab feeder. Sizing the tab feeder. This is number 1. I'm going to do this one as a number 1. Where's the tab feeder? The feeder that we're tabbing. That red thing. The red thing. We're going to size the feeder that we're going to tab. The feeder that we're going to tab. This red feeder, not the black ones. Okay. Anybody want to help chat sizing yet? How do we size the feeder? Did you put anything in the coffee for me? Sounds like this. Anybody wants to help chat, guys? Tab the 600. How do we size a conductor for 600 amp? That's a question. Okay, you take the 600 amp. Where are you going to take it? Mr. Erbab, you and I were working on it this morning at 7 o'clock. Where are you going to take the conductor 600 amp to? 310.16, right? Very good. Thank you, buddy. 310.16. Which column? Muhammad, my friend, which column? Got you out of whack? Okay, 75. Anybody knows what 75? More than 100, more than 100. 75 degree column. Let's carry one conductor this time. It might be a good idea to parallel, but this time let's carry one conductor. Now, DJ, what's the size of the conductor that can carry 600 amp? One single conductor in every phase, of course. 1500? It's a big boy. Let's just, for the sake of it, leave it here, 1500. How many do I need of them? This is a 3-phase system feeding panels. 3-phase system feeding panels. I'm going to size the phases first, and then I'm going to size the neutral. I have a 600 amp, so let's size the phases. For the phases, let's go ahead and size the phases, and that will be 3 conductors, and how many of them? 1500 kc and amp. And what insulation, if you don't know? THHN, unless you know otherwise. These are for phases, for the 3 phases. Okay. Anybody has a problem with that? Anybody has a problem with that? We have 1500 kcm, 3 conductors. That's the feeder. The same thing, sizing the tab for the feeder. The second thing I'm going to size is the neutral. The same thing, we're still in neutral. The neutral, my friends, for the feeder, what do we do with the neutral? The first 200, leave them alone. Anything higher than 200, Brad, cut them by 70%. So here's my 600, take your 600 amp. The first 200, what do we do with them? Don't touch them. Don't touch them. When you take 200 out of a 600, what's your leftover? 400. And what do you do with the 400? You multiply them by 0.7. And you add them up. Multiply them by 0.7 and add them up. Who's my calculator for the day? I need 2 gentlemen, or a gentleman and a lady agree on one thing. That does not include DJ. 480. Anybody came up with 480? Did you add the 0.7 multiplied? 480? 480 amps. Okay. What's the code reference for this 220.61? I'm going to say 220.61. 220.61, right? 220.61. 220.61. Wow, Chad, you got it. All right, 220.61. The reference for this one is 220.61. 220.61. Okay. Any question, my friends? Any questions so far? So we find the amps. Then we're going to come over here and we're going to take the 480 amps. And where do you think we're going to shoot these amps? To 310.16 under which column and why? 75 degree and why? Why 75 degree? More than 100. You can hear Chad talk about this all the time. How many conductors do I need for these neutrons? One conductor. What size that can carry 480 amps? 800. That's a big boy. 800 kcm. What insulation? THHN, unless you know otherwise. THHN, unless you know otherwise. Okay. So what did we do, guys? We sized the feeder first. First, we size our feeder. So I'm going to go back here and take my feeder and say I need 3 conductors, number 1500 kc and m, and 1 conductor, number 800 kc and m. And everybody knows why 3, and everybody knows why 1. 3 the phases, and 1 is the neutral. Any individual has a problem with that? No?
Oh, why did you say THHN? I thought it was THHW. In the 90 right here.
THHW would be outside.
Yeah, if you're using THSW, you're going to use it outside.
Yeah.
If you don't know where the feeder is located, the assumption is located in a dry location.
Okay.
So we use THHN. THHN exists under 75, doesn't it? And also under 90. And we know why we don't go to the 90. 90 is only for derating. Derating. Only for derating. Any question is, so we size the feeder. As long as we're on sizing the feeder, my friends, let's just complete the sizing since you guys are designers and engineers. Let's go size what's left over from, we have a neutral, 3 phases. What another conductor I need? Grounding conductor, assuming there's a PVC conduit coming here. And we need a grounding conductor. Let's go size it as long as we're on it, right? How about equipment, grounding conductor, and everything that I've done here under 1 is still for the feeder. So everybody knows that how we size this. We take the 600 amp, take it to table 2, 50.1, 2, and 2, and that will get me number 1. How many? 1. 1 number 1. 1 number 1 A, W, and a G. So I go over here to complete my size of this boy. 1 number 1 A, W, G. So how many conductors do I have in this coming to this gutter? 5 conductors, 3 phase, neutral, and a ground. Typically, that's what you're going to do. Had this conduit and gutter coming between the circuit breaker box and the gutter is an EMT conduit, metallic, everything is metallic. Do I need the equipment grounding conductor? No. Generally speaking, no. Code-wise, no. Any question, guys? So we didn't do anything here. We didn't do anything with the tabs yet. We just sized. What did we size? We just sized the feeder. The feeder that we're going to be tapping. The feeder that we're going to be tapping. Any question about the feeder that we're going to be tapping? Okay. Now let's go size the tapped conductors, the conductor that we will tap. The tapped conductors. So I'm going to call this one. Can you guys do me a favor? Add, which color are we going to use here? Add number 1 to here. Come on, Chad, get me. There you go. That's number 1. I'm going to size this one. This will be my number 2. And this overcome picture device will be my number 3. Okay? And what do you guys think this one's going to be? This is number 4. And this will be my number 5, based on my numbering system. I already sized everything for number 1, right? And I'm going to go size everything for number 2, and number 3, and number 4, and number 5. And then we'll stop. Any question? Okay, can I move on to the other slide when you guys have a chance? Okay. I'm going to move to the next slide. Okay, my next slide, guys, it's going to be number. I want you to keep an eye on where we were. We need to size number 2. Number 2. What was number 2? Is tabbed conductor, or tab feeder conductors. Let's use the technical term for it. Tabbed feeder conductors. And we specified exactly what number 2 is. Number 2 is a feeder, and that's a tab conductor. Okay, so the rule, here's the rule. It's a 10-foot, I want to remind you guys, it's a 10, not 20, Chad. It's a 10-foot tab. 10-foot tab. Because it's a 10-foot tab, the tab conductor cannot be less than 1/10 of the overcurrent protection device. That's a rule. 1/10 of the overcurrent protection device. That's the smallest conductor. The smallest conductor that we can tab out of this feeder is 1/10 of the overcurrent protection device. Okay, piece of cake, Chad. What's the overcurrent protection device? 600. What's 1/10 of 600? 60 amp. Okay, let's go size the conductor. 110.16 under 60 amps tab conductor. Unless I know otherwise, unless I know that the termination is rated for 75, 60 amp, what do? 60-degree column. Unless they tell you otherwise. I have no idea what termination do I have here. All what I know is it's just a 60 amps, 100 or less under 60. So go find me on the 60-degree column a conductor. How many conductors do I need to tab? 3 conductors, the 3-phase, and then I need a neutral, right? And I need a ground. Since the 60 amps are less than 200, guys, so my neutral will be what? The same size as the hots. Look at the amps here that I'm tabbing for. Right? I'm tabbing at 60 amps. This is completely way less than 200. So I can't do it for neutral anyway. That's why I'm going to size now 4 conductors. 3-phase and a neutral all in one. It's the same calculation. So that will give me 4 conductors. How many, what size under 60? Only 4? 4. Number 4, AWG. AWG. The smallest conductor that you can tab out of this boy is number 4. The smallest conductor that you can tab is number 4. The smallest conductor is number 4. Why 4 conductors, Spencer? Because 3-phase and a neutral. Why didn't I do the calculation for a neutral here? Because it's less than 200. Because we usually say 200 and then anything higher than 200. Do you have anything higher than 200 here? So we're stuck.
I have a question.
Yes, sir.
The 10-foot feeder tab says tab conductors must have a capacity not less than 10%.
Not less than
of the
that's.
overcurrent protection device. So
Yes.
they could be higher.
Oh yeah, I can tab 500 kcm from this feeder. Bring it on. I can the key point. This is the minimum, guys. I can't emphasize. This is minimum. Minimum. Can you guys write this is minimum? Minimum conductor size. Can I tab higher than that? 1/0, 2/0. Bring it on. No problem.
You can tap up to 100%.
You can tab, yeah, you can tab all the way up to, actually you can go higher than that. It's like 1500 kcm. I can tab, it's not smart, but I can tab 2000 kcm out of 500 kcm if I want to, as long as I protect them. 2000 out of, it doesn't make sense. You tab to tab a conductor from a smaller conductor. But you can go higher as high as you want. Lower, that's your limit. Very, very important. We're looking at the limit. Can I tab a number 8 here? No. Can I tab a number 2? Yes. Number 3? Yes. Number 6? No. Number 8? No. Number 5? Do we have number 5? No. That was a joke. Why don't they have number 5? Anybody ever ask themselves? No idea. They followed the steel gauge 100 years ago, and that's how these numbers came to be, up to my knowledge anyway. Any question, guys? We're cool. Let's go. Since we so we found the conductors. That's the first thing I want to find. The second thing I want to find, guys, for this boy is the overcome protection device. Remember, that's number 2. Number 2. I will get back to the conductor, guys. Number 3, I believe. We need over current protection device. Okay. Let's see the conductors I need to tap. 60 amp conductors. Take these 1 to 2 to 40.6. What overcome protection device can get me to 40.6? 60? Okay, we hit the jackpot. So 60 amp. Here's the question that DJ you're going to ask yourself. Can number 4 be protected by 60 amps? Yes. Can number 4 give me a 60 amp? Yes, because we already sized it at the top, so we're cool. If you end up a situation, Ryan, my friend, where your conductor is number 8 here, and you end up with a 60 here, can you do that? No. You have to go lower, either up the conductor or lower the overcome protection device. The conductor and the overcome protection device, because they're tabbed, they have to match. Okay. And I'm going to go back one step, guys, and size the equipment on conductor, because I didn't size it here. I needed the overcome protection device first. So I go 60 amp, size the equipment grounding conductor. I went to the overcome protection device because I need it. And go to which table? 250.122. 122. 250.122, that's the table. And if you go there, what do you get? One conductor number 10AWG. I need that one, right? 4 conductors for the 3 phases and the neutral, and an equivalent grounding conductor. Unless I'm using AMT, rigid, intermediate, any of these metallic business. Why did I do the overcome protection device first, guys? Because how would you size the equivalent ground conductor? You need the overcome protection device, don't you? Okay. Any question, guys, about this number 2 and number 3? Any question about number 2 and number 3? So I'm going to go back to my step, and I'm going to go write the sizes right on it. Can you give me the sizes, Holly, again? The 4 conductors. Number 4. AWG and 1 conductor number 10 AW and G. I just went back and I wrote what I calculated, and what was the amp on that boy? 60 amp. Now we satisfied the code, 60 amps. We're going to do the same thing for the 25. Now if I give you multiple feeders, guys, here, you can tap them the same way. As long as can I go right now and tap another conductor number 1/0 from here? No problem. 10 foot, no problem, Chad. 10 foot, no problem. Any conductor, as long as the conductor is number 4 or larger, you can tap it. Okay, so I just went and I added the sizes of the conductors. Number 4 AWG and 1 number 10 AWG. Okay, I'm going to go, guys, and tab back, and I'm going to go to another page, and that will be number 4. Number 4. And no, we went 3. Number 4. That will be 225 foot tabbed conductors.
3 was the overcome protection device.
3 was the overcome protection device, no?
60.
Okay, so, all right, what's the rule for 25 in terms of amps? The rule says the feeder conductors cannot be less than 1/3 of the overcome protection device. Okay, so feeder conductors. Let's have a conductor here. less or equal to 1/3 times the overcurrent protection device. That's a rule. That's a tab rule, 20-foot tab rule. Not 10, 20 foot. Equal or less. Equal or the conductor had to be equal or more. Equal or more, right? The conductor amp, the conductors, feeder conductors must be, and when we say that, guys, feeder conductor amps, that's what we're talking about. Feeder conductor amps must be more or equal to 1/3 of the overcurrent protection device. Okay, so let's do that.
Less than 1/3.
So let's take a 1/3 multiply by, what's the overcurrent protection device, guys? 600. What's 1/3 of 600? 200 amp. Last time we checked, Chad. 200. Okay, let's take the 200 amp. Where do we take them all the time? 310.16 under 75-degree column. Don't ask me why. 75-degree column, right? More than 100. And how many conductors? And do I need to calculate for the neutral? Look at it. Do I need to do calculation special for the neutral? Why? It's 200. I didn't exceed the 200. So it's going to be 4 conductors. How many conductors? 4. Why 4? 3 phases, 1 neutral. Why didn't I do a separate calculation for the neutral? Because we're less than 200. No need for that. Okay, what's the size DGO or poly? 1/0? 1/0 or 3/0? 3/0?
Yeah.
Under
Oh,
75.
Yeah.
Under 75. 3/0? Okay. Number 3/0. AWG. Anybody has any problem with that? 3/0. Okay. I want to size the equipment grounding conductor, but I need to wait, guys, until I size the overcurrent protection device. So I'm going to go 5. Overcurrent protection device. This overcurrent protection device, everybody knows it's not at the source of the power, at the sink. This is at the end, not at the point where the conductor gets the power. At the end of the conductor, that one that we're sizing, all of them at the end. That's why we have tab conductors. Okay, what was, let's take 200 amps. Take the 200 amps to 240.6. What would you get? 200 amps. Dot, Chad. 200 amps. Okay? So my overcurrent protection device is 200 amps. I'm going to go back, guys, and take my 200 amps. I need to find equipment grounding conductor. 200 amps. Take this one to table 250.1, 2, and 2. And what would that give you?
6.
How much?
6.
How many of them?
1.
One conductor, number 6. One conductor, number 6. A, W, and G. One conductor, number 6, A, W, G. Any question, guys? Yes, sir.
When I got lost right at the beginning, what did you have to do to get the 200 amps?
Okay.
Oh, you took a third time 600.
Third times
Where did the
600.
600 come from?
The 600 is the overcurrent protection device for the feeder.
Oh, that's 600.
Yeah. The 600 amp, I see. See the 600 amp right at the head of the feeder.
Right.
The reason why they do it this way, guys, because the 600 amp is if there's a short circuit in, so can I 3/0 and 1/6? I'm going to go back and just write these one more, write them here. If you guys don't mind, where's my feeder? I'm going to write them in a different color. I'm going to write them right in here. So what did they say? 4 conductors number, what is it, 1/0 or 4/0? 3/0? 3/0? 3/0. A, W, and G, and one conductor number 6, A, W, and G. Okay, I just wrote them. And what was the overcurrent protection device? 200 amp. Overcurrent protection device was 200 amp. Now, if there's a short circuit, here's a question for you. If there's a short circuit anywhere in this feeder or this feeder, in these 2 panels, which circuit breaker do you think is going to trip right inside the panel? Right in this panel. There's a circuit breaker right in this panel, in this area here. Which circuit breaker should trip? The 60. How about in this panel here? The 200. If there's a short circuit right in the tab conductor here, right here or here, which circuit breaker is going to trip? Always the one ahead of it. Which one is the one ahead of it? The 600. That's why they want to limit you. They don't want these, in case of a short circuit, to burn. Otherwise, they burn. If this is too high for them, it will burn, right? And if there's a short circuit in the main feeder, of course, the circuit, the 600 amp will trip. That's why that limitation of 1/10 and 1/3, guys, are there, because if you use smaller conductor than 1/10 for 10 and 1/3 for 20, smaller conductor, then this conductor will burn in the process of a short circuit, and you don't want fire, right? Remember, the NEC code book is written by firefighters. Well, not really, but for the firefighters. Everything is fire. Any question, guys? There are tabs from transformers, primary and secondary. I'm going to leave these guys until the commercial industrial. We go over them because that's where they fit. We will talk about the other tabs from transformer, tabbing the secondary of the transformer, and 10 foot and 25 feet and outside tabs and all this good stuff. We're going to cover them in a commercial project. Any question? Yes, sir.
I thought that on top green, when you say 1500 kcm, number 8, I think it's 8,000, 800, sorry. Is it 800 kcm?
The number 8, yeah, that was 800. That was size it. Very good point, Mr. Bell. At least one of us is awake. This should be 800. Everybody got that one, guys?
What?
The 1500 kcm number 800 here. The neutral is 800, not 8. Thank you. Very good observation. These two zeros just got dropped somewhere. But everybody, we wrote them right down here, right? 600 right here. We wrote them right here, guys. The 800. Good point. Good observation. Thank you. Any question, guys? Okay, let's take a 5 minutes break and then I'll go over transformers.